all of these. Okay, so we're just going to start here with this first one. So if we have a flat line on a position time graph with no slope, our y-axis value is the same for every single point along this line. That means for this line, we are standing still. We could say that we are in a positive position, okay, because we are above the x-axis, but that's really the most that we could say about this graph. Okay, for the second graph, we have a positive slope. We also are, we have a starting position above 0. So starting position larger than 0. Moving forward, and I'm going to say slowly because I look at this and I interpret this as not a super steep curve, or I'm sorry, not a super steep slope. I would say that this down here, this one that we're going to get to, this is a steep slope, but this slope is not as steep. Okay. So for this one, this next one, we also have starting position larger than 0. Now we are moving backward. And do we see how we're moving backward because we have a negative slope? And I'm going to say very slowly just because we're moving slower than the graph above. Okay. All of this is a comparison. As long as your answers are logical within the graphs that we are, within all of the graphs we're working with for that specific assignment, I think you're fine, okay? It would be incorrect if you said that this graph right here, let's call this graph number 3. Let's just number these. I think it makes it a little bit easier. And this is number 1. So if you were comparing graphs 2 and 3, and you said graph 3 is moving fast and graph 2 is moving slow, that would not make sense, right? So you want to just make sure it makes sense with respect to the graphs around it. Okay, so for the second part, we have 2 different, again, just kind of follow this and just label this number 4. I have 2 different movements, so I'm just going to describe the first movement first. So starting position greater than 0. Moving backward, because we have a negative slope, quickly. Then standing still in a positive position. Okay? That's the most we can really say about this. We don't have any numbers to go off of. We can only describe this qualitatively. Moving on to this next one. Again, let's just label this number 5. Okay, so written description. So again, we have 2 different movements. So origin at 0, moving quickly in a forward direction, then turn around. So if I'm turning around, that just means I'm now moving in the opposite direction. So now I'm moving backward, slower. So at a slower pace. So I really want to make sure that I am describing both situations here. Okay, so first for this next one, we start at the origin. Actually, origin at 0, sorry. Origin at 0. Moving forward slowly, then continue forward, but move more quickly. Okay. So this next one, this would be number 7. So we have 3 different movements here. So we are origin in a positive position, moving forward, and we're moving forward slowly, like compared to the other movement within this graph. Then stand still, then move backward to 0 quickly. Okay. As you're writing these, you really want to make sure that you are differentiating between the different movements. Okay, so that's why I'm writing in all caps then, okay, and I'm like hitting enter, I'm making a new line, okay, I'm trying to be as clear as possible that there are 3 different movements here. Oh, this one's actually numbered. Okay, so number 8, we are moving backward quickly, so origin in a positive direction, moving backward quickly, then stand still, then turn around and move forward slowly. Okay. Okay, so this next one. This is a velocity time graph. I'm not expecting that anyone was able to look at this and just right off the bat like know what this is saying. So here's my hint for this. Do you see here with number 8 in the second movement, here where we have a flat line? A flat line in a position time graph means that we're standing still because our y-axis is position. And if we have a flat line with no slope, our position is constant because our y-axis value is constant. So here in this velocity time graph, whoops, so I just want to be very clear, this will not be on Thursday's quiz, okay? So here with this velocity time graph, if we have a flat line on a velocity time graph, that means that we have constant velocity. Just like if we have a flat line on a position time graph, that means we have constant position. So we have constant velocity. Okay. We are moving forward because our constant velocity is 4 meters per second. So constant velocity at positive 4 meters per second. So that means that we are moving forward at 4 meters per second. Okay. That's really all that we can pull from this. But yeah, this is not going to be on Thursday's quiz. I want to be very, very clear with that. Okay.